In this video, we will learn about magnetic field due to a current in a solenoid. So, we know that a solenoid is a coil of large number of insulated copper wires wrapped closely in the shape of a cylinder. Generally, the length of the solenoid is much greater as compared to its diameter. This is the diameter, this is the length. Length is much greater than the diameter. Okay, and the turns of copper wire are wound on hollow cardboard tube AB. Okay, like this. So when the two ends of the solenoid coil are connected to a battery B, key K, rheostat RH, and ammeter A in series, and a key is plugged, as you can see in this particular diagram. This is the ammeter like this. So we see that a magnetic field is generated inside the solenoid as well as around it. And this is the magnetic field, right? So if it is the north side and if it is the south side, field lines are coming out of the north and going in the south. Okay. Now the pattern of magnetic field around the current carrying solenoid is shown in this particular figure. Now as the current in each circular loop of a solenoid coil is in the same direction, the magnetic field of all the loops are added up, and as a result the magnetic field inside the solenoid coil becomes a strong field. That is, this field becomes a strong field. Now, the field pattern of a solenoid is similar to the field pattern around a bar magnet. Now, for the direction, now depending upon the direction of the current flow, one end of the solenoid behave as north pole and one behaves as south pole. The end of the solenoid where current is seen to be flowing is clockwise direction and act as south pole. So, clockwise means south pole, okay, and anti-clockwise would mean that it is north pole. Now, on the other hand, the end of the solenoid, where current is seen to be flowing in an anti-clockwise direction, it acts as north pole of the magnet. Now, the magnetic field lines inside the solenoid are in the form of parallel straight lines. This signifies that the magnetic field inside the current carrying solenoid is uniform magnetic field. Now, strength of a magnetic field inside a solenoid. So, the magnetic field B is directly proportional to the current flowing through the solenoid coil. Now, the magnetic field is directly proportional to the number of turns per unit length. Turns per unit length is denoted by small n, and magnetic field is directly proportional to small n. So if the turns in a solenoid coil wrap closely, then number of turns per unit length will become more and a stronger magnetic field is produced. Thirdly, if a rod of soft iron or steel is introduced as the core material inside the solenoid coil, the magnetic field generated inside the solenoid increases by a large factor. Okay, please remember this as a fact, please. The fourth point is that the magnetic field of a solenoid does not depend on the dimensions of solenoid. Okay, so these two are exclusive points for solenoid, right? So please remember them accordingly. Now, comparison of magnetic field of a current carrying solenoid and a bar magnet. So we have seen that magnetic field of a current carrying solenoid is similar to that of bar magnet. One end of the solenoid coil behaves like a north pole and the other behaves like south pole. Moreover, inside the solenoid, field lines are parallel just like a bar magnet. Secondly, a current carrying solenoid exhibits the directive property as well as attractive property of a bar magnet. Thirdly, the strength of a solenoid can be changed easily by changing the current flowing through it, but the field strength of a bar magnet cannot be changed. Fourth is that the direction of magnetic field due to a current carrying solenoid can be reversed, but not possible in bar magnet. Okay. Now, what are the uses of a solenoid? So when a piece of magnetic material like soft iron is placed inside a solenoid coil, it is magnetized due to the strong magnetic field produced inside the solenoid on passing a current. Now the magnetization lasts so long as the current is flowing. Thus, the solenoid coil can be used to produce electromagnets of appropriate power. I hope this topic is clear to you. Thank you.